Hey everyone, welcome to another quantitative reasoning video. This video is going to focus on scientific notation, and I am sure that many of you have seen this before, and probably at least part of you were taught to move the decimal point to the left, move the decimal point to the right, and if you understand that and you know it and you remember it, that's great. But the problem with that is it doesn't really require any kind of understanding. And so I want to give you a little bit better background for that. So the idea here is this: scientific notation looks like a number between 1 and 10, including 1 but not including 10. So a 1 digit with some decimal point numbers afterwards, just a number in the ones place, and then some decimal points afterwards maybe, and then multiplying by a power of 10. So what we need to talk about first before we get into this is this idea of positive and negative power. So just a reminder that 10 to the third power, what does that mean? That means 10 times 10 times 10. If you put that in your calculator, you get 1,000, right? But what about 10 to the negative 3 power? What does that mean? Well, 10 to the negative 3 power, the negative power means that you are flipping over the base. So instead of being 10 to the negative 3, it's the same as 1 over 10 to the third. And the reason behind that, mathematical notation, basically the idea is that the negative means an inverse or an opposite, right? So plus 3 and minus 3, they're opposites of each other, right? Well, what's the opposite of multiplication? The opposite of multiplication is dividing. And so because the opposite of multiplication is dividing, then that's where you get 1 over 10 to the third power. So 10 to the third power is 1,000. 10 to the negative 3 power is 1 over 1,000. All right, now let's talk about consequences here. If I multiply by 10 to the third, then I'm going to increase my value by 1,000. But if I multiply by 10 to the negative 3, I'm going to decrease my value by 1,000. And so now come back to our scientific notation. Problem number 1, we have 8.86 times 10 to the negative 2. Is 10 to the negative 2 a big or a small number? Well, it's small because 10 to the negative 2 is the same as 1 over 10 squared. So I'm dividing by 10 squared when I multiply by 10 to the negative 2. If I divide by 100, is that going to make my number smaller or bigger? Sure, it's going to make my number smaller. And so each decimal place is a power of 10. And so what do I need? I had 8.86. I need 2 decimal places in the left direction, not because I moved to the left, but because going to the left makes the number smaller. Okay? Whereas if you take a look at number 7, here we're multiplying by 10 to the 6th power. 10 to the 6th power is very large. That's 1 million actually. And so what do I need to do? I need to take my 4.1 and I need to have enough zeros over here so that I can move my decimal point 6 places. 1, 2, 3, 4, 5, 6 places. All right, and so that ends up giving me 4,100,000. Again, I don't memorize that, oh, it's a positive, I move it to the right. I say 10 to the 6th power is a very large number, and so therefore 4.1 times 10 to the 6th is a very large number, and I get larger by moving to the right. So if you memorize it right and left, that's fine by me. Just understand that you need to be able to apply it properly. And so one of the ways to apply it properly is to understand what you're doing. If we're going the other direction, like number 11, we have 0.000004. So first of all, I have to make that a number that is between 1 and 10, not including 10, a 1-digit number, units digits anyway. And so I move this decimal point 1, 2, 3, 4, 5, 6 places, and I get to 4.0, just 4. Now, was this number over here a lot smaller than 4 or a lot bigger than 4? It was a lot smaller than 4, right? Which means to keep the balance, I need to multiply by a very small number, and that's going to mean I need a negative power, and of course I moved 6 places, so that's 4 times 10 to the negative 6th power. Okay. Whereas for something like 15, 4,390, I take this decimal point and I move it 1, 2, 3 spots. Again, you only want one number to the left of the decimal point. You must have exactly one number to the left of the decimal point in order to be in scientific notation. Compared to 4.39, is 4,390 larger or smaller? 4.39 is a lot smaller than 4,390, so to keep the balance, I have to take 4.39 and multiply it by a larger number, so that's 1, 2, 3 powers of 10, but I need positive 3 because it's a larger value. Okay? So I'm not going to take the time for examples, for you to do examples. These are pretty straightforward problems. Just wanted to give you a couple of samples for them, and now you go through the worksheet and finish them off. The answers will be posted in D2L, and you should be solid on that. If you have any questions, as always, reach out and check in with me. Thanks. See ya.